In this lesson, we're going to introduce our new unit, which is quadratic expressions, and we're going to learn how to multiply binomials. So before we do that, let's look at a few new words and what they mean. So we have a list of terms here that are going to be used. Some of them we have already used before. So the word constant, we have come across that before. That is just a term without a variable, or also something that is just a number. So there's no letters with it. We have also seen the word variable, which is a letter that is standing in for a number. And we've seen the word term before. So that's just a combination of numbers and variables that are forming a product. So that just means that we are multiplying those together. So for example, we might have 3x squared y. So they're forming a product, which means they're being multiplied. There's no addition or subtraction there. We have also seen the word expression before. So algebraic, just talking about the fact that there are variables or letters in there. So an expression is a series of terms. So a series just means we have multiple terms, more than one, and they're separated by an addition or a subtraction. So all terms are things that have numbers and or letters that are being multiplied together. So anytime we see an addition or a subtraction, we have a new term. So an algebraic expression is just multiple terms separated by addition or subtraction. So let's look at some of our new words then. You can see that a lot of them end with meal here. So a polynomial, the word poly just means many. So it's an algebraic expression with many terms. Then we have a monomial. So a monomial is an algebraic expression that has only one term. Mono means one, bi means two, think bicycle and two wheels. So a binomial is an algebraic expression with two terms. And a trinomial, tricycle, three wheels, trinomial, an algebraic expression with three terms. So a monomial, we're going to take a look at those right now. A monomial might be something like 4n cubed. So we only have one term there. We don't see any plus or minus. A binomial, this could be something like x plus 5. So we see a plus there, which means we have two separate terms. This one has a variable, and this one only has a constant, so there's no letter with it. And a trinomial might be something like 3x squared minus 2x plus 7. So here I have 1, 2, 3 different terms. So every time I see a subtraction or an addition, I have a new term there. So these are going to be words that we use now throughout this unit and the next, so you'll get comfortable with them. So over here we have monomials that are being multiplied together, and this is something that you have done already. So we'll do a few of these examples together. So when I have something being multiplied by itself, first of all, when I have a letter that doesn't have any exponent, the exponent is always 1. So this is really z to the exponent 1 times z to the exponent 1. And I can simplify that. So remember that if I have 3 squared, what it really means is 3 times 3. So it means the same number, the same number here is being multiplied by itself, and this many times, 2 times. So I see the number 3, 1, 2 times, and it's being multiplied. So z times z, I can rewrite, and I can take that exponent of 1 from the first one, and I can add together the next exponent from the other one. So 1 plus 1 is equal to 2. So z times z, I can simplify that to z squared. Over here, y squared times y. So y squared just means y times y. And then I'm multiplying it by one more y. So in the end, I have 3 y's being multiplied. So y to the exponent 3. And I can show I have y to the exponent 2 plus 1. So y to the exponent 3, or y cubed. Now once we have coefficients, remember that's the number in front of a variable, we can take a look at that and say that this is a 2, and over here there's no number, so it's really a 1. So 2 times 1 is equal to 2. And then I have g to the exponent 1 times g to the exponent 2. So I can also see this as I have a 2 here. That's being multiplied by a g. And then that's being multiplied here by a 1. And then a g and another g. So g squared is 2g's being multiplied. So when I simplify, what I can do is I can put all my coefficients together. So I have a 2 times 1. That's equal to 2. And then I have g times g times g. So I have 3 g's being multiplied, which means g to the exponent 3. Over here, I have 3, and I'm going to write all of my numbers first. So I have a 3 here, and that's being multiplied by another 3. Then I'm going to write all of the f's. So I have an f here and an f here. And then I just have the 1g. So I'm going to simplify that. 3 times 3 is 9. F times f is f squared, and then I just have the 1g. In this question, I have a 3 times a 2, and then I have an e, and I'm going to write the short form. So e squared times e to the exponent 1, so then I add my exponents. So this equals 6e cubed. So leave the rest of these examples for you to try on your own if you're watching the video, and you can go into Content Library to check your answers for the other ones. So those are questions you probably did in grade 9 already. We are going to recap now multiplying monomials by binomials. You might last year have called this distributive property because you probably didn't know the words monomial and binomial yet. So I have a monomial here. The x is just one term, and that is being multiplied by x plus 2, and this is a binomial. So I have the x and the 2, they're separated by the plus, so there are 2 different terms there. So last year we called this distributive property. You took whatever was out in front of the bracket and multiplied it by each of the terms inside of the bracket. So here we have an x times an x, and that is x squared. And then we have an x times a 2, and we always write our numbers first. So that is a 2x. Now we have a positive number being multiplied by a positive number, and that's going to help us figure out that what separates our 2 terms is an addition and not a subtraction. So x times 2 is 2x. Here I have 2b times a. So positive times a positive, my answer is a positive. Numbers, I have 2. Then I have a b times an a, and I always write these alphabetically. So I'm actually going to write the a first and then the b. Order of multiplication doesn't matter, so think 3 times 4 equals 12. If I flip that around, 4 times 3 also equals 12. So the order that I write things that are being multiplied, it doesn't matter. When we use letters, we write them in alphabetical order, just so somebody doesn't get confused that 2ab and negative 4ba are really like terms, and you would be able to add them together. So it just keeps it easier for us. So that's our first one. 2b times a is 2ab, and then I have 2b times negative b. So sometimes it's helpful to see a coefficient of 1 if our coefficient isn't written. So I have a 2 times a negative 1. The answer is a negative 2, so that's going to help me to determine that my sign is a subtraction and not an addition here. Then I have b times b, which is b squared. So over here I have 2mn times n. I have a 2. I have m times m, which is m squared, and I have an n. And then, because I have two positives, I'm going to be adding. Now I have 2mn times n. So I have 2, and m to the exponent 1, and n to the exponent 2. We'll try 1 over here. So here I have a cubed times 2ab. So for numbers, I have 1 times 2, which is 2. Then I have a cubed times a, so in total I have a to the exponent 4, and then I have a b. Then I have a positive times a negative, so I'm going to be subtracting. 1 times 1 is just 1, which I don't have to write, and then I have an a cubed and a c. I don't have any a's over here or any c's over here, so I don't have to use my exponent rules here. So just a quick summary. Hopefully you remember this from grade 9. When you're multiplying the same variable, so if you have x squared times x to the exponent 5, you can just add the exponents together. So in this case, 2 plus 5 is 7, so your answer would be x exponent 7. So x squared means x times x. And then if you're multiplying that by x to the exponent 5, you're multiplying by 1, 2, 3, 4, 5 x's. And in the end, if we put this all together, we can say we have 1, 2, 3, 4, 5, 6, 7 x's that are being multiplied together, which is what x exponent 7 means. Okay, let's take these skills that we have from grade 9 and use them when we have two binomials that multiply together. So this here is two binomials. I have an x and a 1 and an x and a 2, and these are being multiplied. So we're actually going to use distributive property again, just like we used it before. But this time, because we have two terms in front in our first bracket, we are going to multiply every term in the first binomial by every term in the second binomial. And we have a term that can help us to remember how that happens, and it is called FOIL. So FOIL just stands for, so the F is first. So first we multiply the first terms in our brackets. So x is the first term in this bracket, and x is the first term in this bracket. So first we take our first two terms and multiply them together. Then we take our outside terms and multiply them together. So this is the outside and this is the outside. So we're just looking at either end really. So the x multiplies by the -3 here. And then we take our I, which is our inside, and that is over here. So if we see these as our outside terms, these are our inside terms. So the +2 multiplies by the x, and then our last terms, and that is the last term in the bracket. So the +2 multiplies by the -3. So you can use that to help you. It also says that every term in this bracket multiplies by every term in this bracket. So the other way to see it is we start with our first term and we multiply that through by every term in the second bracket, and then we move to our next term and multiply it through by everything in the second bracket. So this is true no matter what kind of polynomial you have. Every single term in your first bracket you'll multiply by every term in your second bracket, and then move on to the next one, and so on. So let's take a look at what that looks like. So We are first going to do this. We're going to multiply each term in the first binomial by each term in the second binomial, and we can use those arrows that I drew in here. That can help us, especially as we get started, and it can help to make sure that we don't miss anything. Then we're going to collect any like terms, so things that have the same variable and exponent. What you're going to eventually see is that it's our outside and inside usually that are our like terms. And then we're going to organize our terms in descending order of degree. So that just means that we're going to take our variables with the highest exponent and write them first, and then end up with our constant with no variable at the end. So let's take a look at some examples. So I have x plus 1 times x plus 2. So I'm taking my first term and multiplying it by the first term in my second bracket. So x times x is equal to x squared. Then I'm taking my first term and I'm multiplying by the second term. X times 2 is 2x. And because they're both positives, I'm going to be adding. So anytime I have two positives or two negatives being multiplied, I'm going to be adding. Then I'm moving to the inside. So I'm moving to the next term and multiplying by the first term in the second bracket. So 1 times x, that's a 1x. And then I have my last, so 1 times 2, and that's a positive 2. Now I can see here that I have a plus 2x and a plus 1x. Those are like terms, so I'm going to put them together. So I have x squared plus 2x plus 1x is plus 3x, and then plus 2. So let's try another one of these. So I have z times z, that's z squared. Z times negative 4 is negative 4z. 2 times z is 2z. And 2 times negative 4 is negative 8. Now when we add these, we want to make sure that if we have a subtraction here, that this is a negative 4. So I'm not doing negative, whatever 4 plus 2 is, so 6, but I'm doing negative 4 plus 2. And whatever my sign is in the end is going to be my sign for my new term once I've simplified. So negative 4 plus 2 is equal to negative 2, and then z minus 8. All right, let's try one more example where we have coefficients in front of our variable. So here I have a 2j times a 3j. So 2 times 3 is 6, and j times j is j squared. Then I have a 2j times negative 2. So 2 times negative 2 is negative 4, and there was just the 1j. 1 times 3j, both are positive, so I'm adding. 1 times 3 is 3, and the 1j. And then 1 times negative 2, subtract 2. So here I have a negative 4 plus 3. Both of them are j, so those are like terms. So I have 6j squared. Minus 4j plus 3j is negative 1j. And I don't have to write the coefficient of 1. So I can either write 6j squared minus 1j minus 2, or just 6j squared minus j minus 2. Okay, let's actually do one more, which is one like this. So this just means whatever is in here is written again. So especially at the beginning, you probably want to rewrite this where you show the second bracket, and that makes it easier. So we have h times h is h squared. H times 2 is a positive 2h. 2 times h is a positive 2h. And 2 times 2 is a positive 4. Plus 2h plus 2h is plus 4h. And then we have our plus 4. So that's how we multiply binomials together.